In our last presentation, we introduced the kitchen as the heart of the home and the center of both functional and social activities instigated by food, and the robot as a subject of determinism which excels at performing repetitive tasks. In this stark juxtaposition, we sought to find a way to allow our robot to participate in the socialization of the kitchen, and so we formed our research question. We sought not to ask what it is we can make a robot do, but instead ask how we can make a robot behave.
In this pursuit, we introduced the character of the NonnaBot as an agent of traditional Italian culinary tradition into the kitchen. NonnaBot seeks to investigate ways in which cultural food practices and heritage are preserved through behavioral programming in a new age of cooking, where 6-axis industrial robot arms are introduced into our kitchens. In this presentation, we dive deeper into the key areas of our research and explore this through the lens of user narratives. Firstly, we explore the idea of personifying cooking experiences with cultural culinary heritage to differing levels based on the user's desire. Then, we investigate the integration of visual tracking systems to scan and understand kitchen layouts and geometries. Finally, we research the incorporation of hand gestures as a means of communication, expression, and demonstration.
This idea of cooking with Nonna is established by introducing NonnaBot into your existing home kitchen. The NonnaBot is technically rich in that it can scan and capture 3D spatial data of your kitchen to understand its layout and geometry. Rather than developing a purpose-built kitchen to suit a robotic arm, we believe integration into existing conditions will see a much greater preservation impact on culinary traditions and proliferation of robotic arms into kitchens. We have developed 3 user narratives to explore these areas of focus and level of robotic involvement. Firstly, introducing Julia, an architect who has moved from Italy to Sydney for work. She dearly misses her family and in particular, cooking with her Nonna. Secondly, we introduced Luca, an investment banker who loves cooking but works long hours. He wants to cook without the time wasted cleaning the mess he makes in the kitchen afterwards. And finally, we introduced Andrea, an inspiring chef who wants to learn all sorts of recipes and techniques.
As a mode of exploring this question, we have chosen to focus our attention and effort by locating spaghetti carbonara as a locus for cultural contention. In the preparation of this specific dish, we find a tapestry of cultural nuance. Within the methodological confines of this dish, we find many correct ways to perform tasks. However, to cook with many regional permutations, departing from the model of a correct method of dish preparation, we are presented with a rich foundation of food culture for exploration.
Socio-cultural expression is built into the diversity in the ways that our dish can be assembled. Taking, for example, the specific action shell of boiling pasta, we reveal the true complexity of what appears to be a simple process. Here, even more so than in the general arrangement of our recipe, human cooks are presented with a plethora of methodological opportunity. In cooking carbonara, how do individual users address methodological variables? Does a human cook decide to use filtered or unfiltered water? Does a human cook use spaghetti or penne? How well does a human user salt their pasta water? For a robot, there is no availability for choice in this matter. A robot is programmed on rails and performs tasks again and again, to the detriment perhaps of our methodological tapestry. And so, into this space, we introduce our first narrative.
Julia, who has moved from Italy to Sydney for work, dearly misses her family, and in particular, cooking with her Nonna. Cooking with Nonna is a concept that engages the nostalgic experience of Nonna, taking a watchful eye over your cooking in the kitchen. To give a specific example of this in a practical sense, we take the instance of a human cook breaking spaghetti in half before adding it to the boiling water. Although perhaps an acceptable way to boil pasta, Nonna's understanding of cultural norms informs her that a grave culinary sin has occurred.
NonnaBot makes her distaste here clear. This has been deemed an unacceptable way to cook pasta. But NonnaBot is not only reactive. NonnaBot can walk the walk as well as talk the talk and knows how it's done right. NonnaBot has the capacity to be demonstrative as well as reactive.
How do we know if the pasta is ready? Here, we can see the user is about to take the pasta out too early. NonnaBot steps in and is calibrated to check the tensile strength of the pasta to ensure it is al dente. When it is al dente, Nonna gestures to the user that the pasta is ready.
It's perfect.
Questo è fatto.
It's perfectly al dente.
Next, we address another great pasta noodle taboo. In traditional renditions of spaghetti carbonara, the preservation of pasta water is a key element of the dish and is used to thicken the sauce added later to the dish.
To the distaste of NonnaBot, however, this step is most unfortunately on occasion forgotten. NonnaBot observes here a human cook failing to recall this fact. NonnaBot is not happy and this displeasure is expressed. But NonnaBot knows the way and is happy to share her tricks of the trade.
Save some pasta water.
By analyzing existing kitchen layouts, we can see that fixing the robotic arm in a single position does not fully utilize its capabilities as it is unable to interact with multiple work surfaces.
Unlike KUKA robots, your standard Nonna comes with legs fitted as a factory standard. This is more significant than it may on the surface seem. Mobility allows human Nonnas to participate in the kitchen with much greater dynamism than a robot counterpart may be able to do. Could NonnaBot be modified in some way to allow for this greater level of mobility? We have explored a solution that utilizes linear rails to allow NonnaBot to move in the X and Y directions and so broadens her ability to participate in the social realm of the kitchen. Now, after having explored the possibilities for NonnaBot to move about the kitchen, we're able to revisit some of our earlier explorations of NonnaBot in the kitchen. Adding a more dynamic motion creates a richer engagement with human kitchen users and opens NonnaBot up to new potential use cases in the kitchen.
Luca, a busy professional, loves cooking at home in the kitchen and always makes a big mess. He hates cleaning up after himself. NonnaBot relieves the time pressures of cleaning up and is able to do so by moving around the kitchen on its linear track movement systems. In combination with the 3D spatial data tracking capabilities of the NonnaBot, she is able to detect dirty pots and pans. The two-pronged object gripper carries the pots, pans, mugs and places them into the dishwasher.
Andrea, an aspiring chef, wants to learn all sorts of recipes and techniques, but unfortunately currently lacks a mentor. Mentors, unlike textual or audio-visual learning material, are experiential. In place of a physical, instructive presence in the kitchen, we explore the possibilities of our NonnaBot taking on the role of a gentle, instructive hand. In this scenario, NonnaBot has learned and demonstrates the proper way to grip a chef's knife through its fine motor hand motion tracking capabilities and haptic feedback input capability.
Here, NonnaBot demonstrates for the benefit of Andrea how a Nonna with many years of experience in the kitchen would hold a knife. Haptic feedback technology is proposed to be embedded within the gripper hand to help NonnaBot apply adaptive amounts of grip force and also enable NonnaBot to react to the changes in grip conditions.
Often, recipes call for certain sizes in which the ingredients should be cut at. NonnaBot is able to project an overlay of the ideal size at which the guanciale should be cut at.
Hard work is worthy of praise, and so NonnaBot can be supportive as well as critical. When considered appropriate, NonnaBot is able to gesture to indicate a job well done, or even for repeat human offenders, offer a supportive touch.
Today, we have explored the potential for collaboration and dialogue between an industrial robot arm and a human kitchen user. We believe that this method of behavioural collaboration provides far richer opportunities to speculate about ways in which we might preserve the emotive qualities of culinary traditions that are typical of an analogue way of working in a world that is relentlessly digitized and utilitized.
We have positioned the ideas explored throughout this research as a stepping stone for translation to architecture, construction, and fabrication applications. This is achieved through the investigation of live 3D spatial data sets for robotic arms to be integrated on-site, XY track movement systems, macro gripper tools for large object movement, fine motor movements for craftsman-like maneuvers, and projection overlays for accurate site setout. We believe the ideas explored throughout this presentation serve as a starting point for the proliferation of robotic arms into our kitchens as well as wider industries. Thank you.